Всем добрый вечер. Рад присоединиться к дискуссии AI Retail.
Hello everyone. I'm happy to join this AI retail session. So without further ado, let me start my talk on optimizing product photo retouching process for e-commerce and D2C brands with AI.
Сегодня, соответственно, чтобы доклад был достаточно общим, мы поговорим о двух фреймворках.
In my talk, I will mention two proprietary frameworks we developed to help our clients to better structure their business cases, to identify the best use cases for AI, to better describe the data collected on a specific business process, as well as the additional information that's required for better structuring the business process. The second framework is the AI ROI calculator. It allows comparing revenue versus costs and making an informed investment decision on a project, whether it does make sense financially to implement AI for this or that business process. We will illustrate those frameworks using the example of NeuroRetouch. First of all, let me tell you about retouching in retail. So, we take a raw photograph from a studio. So, you see a lot of equipment here, which is used to make a wonderful photograph which complies with all the standards for product images in retail. So it has to have a proper resolution, it has to be optimized, it has to be color adjusted. Currently, this is done manually. Image processing is completely manual, but we decided to develop an IT tool for automating that. Well, first of all, we use the AI process mapping framework to describe this business process. So, first of all, we describe the state, the conditions for transitioning from one state to another, and identifying the entry points, and to answer all those questions which are listed now in the slide. I'm not going to go through all of them in detail. I would like to highlight just three of those questions, which are often neglected by most companies. First of all, the speed of response in the system. In terms of the speed of response, all the systems are divided into real-time systems, or those systems which process packages of images on a regular basis. The reason why it's important is that it directly affects the economics of your projects. Real-time systems are a lot more complicated in development than post-edit systems. And this is one of the first questions you need to answer before you start doing that. The second question is about user experience, is about user adoption and the user behavior. So the question is, what tools are currently used in this business process? It is important because it will drive the integration of our AI-based solution into the existing business process. For people to adopt a new tool, it's important to ensure the good usability of that tool. If an AI-based tool would completely disrupt the business process, well, clearly, we would face an adoption risk because the users would be reluctant to start using this process, and it will become an obstacle to implementation. And the third question is that of data. We need to ask all sorts of correct questions, first of all, to identify whether this data is available, and second, whether we can collect this data. IBM developed this 4V data framework to describe the data. 4V means volume, variety, different forms of data generated by this business process. Velocity, that's the speed of data is created and streamed, and veracity, or reliability of data, because if there are humans involved in this process, they may introduce errors, and we have to mitigate this factor before we implement the AI solution. All those issues are also valid for the IoT applications. If there is additional noise or bias introduced, it has to be mitigated before this data is fed into the model.
So let's apply these two frameworks to the process of retouching commercial photos. Usually the structure of this process is as follows. You either have your own photo studio or you have a freelance photographer whose services you are retaining. So after you have had your products photoed, you need to have them retouched. Usually it's the content team that gets the photo and then uses Adobe Photoshop or Lightroom or similar tools, polishes them up, removes the background, and performs the activities they previously enumerated, as I described the problem. So then you get a nice, sleek photo that you publish in your catalog or elsewhere, where you expect customers to be exposed to it. In fact, the slide has all the stats required. Currently, it's a very routine, very dull, and a very long operation, taking up to 60 minutes per photo. And often companies will be paying 50 rubles per photo or more, depending on the product category. For every product, you need around 5 photos, and large retailers will process something like 1,000 photos per day. So if you simply multiply these numbers, you will realize that this is the right kind of problem for AI. There should be significant value to capture here, but in the following slides we will be able to quantify it. As we apply the 4V data framework from IBM, we can actually describe the kind of problems we have here. Obviously, it's big data because we are generating 100 gigabytes per day, up to 1 terabyte per day. In order to do the retouching, you need the pre- and post photos, or in other words, we need to be able to teach our neural networks or our GANs to actually distinguish between prior and post-facto photos. So the way it's usually done is that companies either have an in-house team of retouchers, but very often teams like this are relatively small, and around peak times, for example, when seasonal catalogs are launched, teams obviously don't scale fast, so people either have to work day and night, or the company has to engage freelancers. This probably means that you will be dealing with not necessarily reliable freelancers, and their work also needs to be coordinated. So this is obviously something that AI could step in and solve quite nicely. So now we understand that AI process mapping and 4V data frameworks can nicely be applied here. Let's look at another framework here, which helps us actually calculate ROI. It's very easy to calculate the benefit using the decomposition method. We take the number of employees involved in the key processes, we multiply it by the salaries they get paid, or per hour wage, whichever applies, and then we multiply it by time spent per operation or per activity and number of activities performed by a single employee. Also, we should multiply it by automation percentage. So the number we get like this will tell us the upper bound for the total value we can get by implementing AI. Why will it be the upper bound? Well, because we always have the costs, right? Upfront costs, running costs, and usually automation is not 100%. You know, the idea of singularity has been hyped up. We keep hearing that robots will conquer the world and we will all be jobless. But in the plenary session, Russian president said we should not be afraid of that. You know, we will control machines, not the other way around. And interesting, you know, conceptually he is right. So all in all, the systems that do get deployed in most cases are, in fact, hybrid intelligence systems. Cyber-physical systems, shall I say, because they combine the strength of machines with the strength of humans, because machines tend to be faster, while humans tend to deliver higher quality results. So it does make sense to combine the two. Now, let's look at expenses now. Actually, calculating costs in AI projects can be quite difficult. You will see here that we have obviously CAPEX and OPEX, but also in each of these subgroups, we can also identify 4 sub-elements, totaling 8. So on the fixed side, this will be, for example, cloud computations required to teach the AI model, purchase of data, data tagging, and so on. How about we discuss the nuances, the speed bumps that non-experts may not be aware of? So first and foremost, we need good data, and I guess this is clearly understood by everybody in the industry. Everybody realizes that you cannot really start a project like this without reliable data. Fortunately, we can actually simplify the learning process by using transfer learning or transfer knowledge. The idea is as follows. We have some publicly available data sets. For example, we have ImageNet and Open Image dataset, and we have other datasets for pictures, so we can use them to pre-train our neural networks. After that, we can collect our own proprietary data, and we need significant smaller volume of it, and then we perform the so-called transfer. That is, we take pictures from the initial data set, we teach our neural network, then we feed it our own pictures, and in the end, we get the final solution. This is how we can actually decrease the effective amount of data required to train our systems. Also, take into account the fact that a number of AI cases do not pay for themselves. The computing expenses as such tend to be pretty high, pretty steep. We can actually use regular CPUs to run, say, a regular website. And you can find it quite easy to actually serve, say, 100,000 or 1 million users for the same website. However, for AI, this will not work. In fact, the salary of a GPU will quite often be comparable to the salaries of your full-time employees. There have been cases when corporations would actually compare the two. I mean, it's unethical, but companies do that. Obviously, computers can perform many more operations per second. And please note that, they tend to be quite costly as well. Now, the next factor is related to the so-called long-tail effect. Unlike, say, development of a mobile app, where a minor addition such as adding a red button in the right-hand top portion of the screen, which can be performed by any engineer, this is more difficult here. Because when you're using industrial-scale AI, there will be lots and lots of situations where AI will fall on its face when faced with reality, because of numerous long-tail scenarios. This is effectively a live system linking AI to the real world. This means that you need to allocate a lot of resources, even after this AI solution has been deployed. More resources than you would have to provide for a regular piece of software, because you need to keep fine-tuning your AI system. Another important component is the so-called hybrid intelligence. End users expect quality. AI still cannot guarantee superb quality in all situations. There may be some bias built into the way that a dataset was built, for example, or the way the learning happened, and it may get critical. Take retouching as an example. Very often, pixel-perfect images are expected to be uploaded to the website, and that still requires involvement of a professional retoucher. That's why we propose a hybrid model where like 95, 98, maybe 99% of all the retouching is done by AI, but the little nuances, the little polishing touches are still added by professionals, and it is the finalized pictures that the clients eventually get so that they can publish them in their catalog. In conclusion, let me point out that deployment of AI in some cases is not feasible. There are some criteria that need to be observed, like you need to be generating a lot of your own data, like Amazon, X5, Sber. They do generate a lot of data. It makes sense for them. Also, it can easily happen that the size of your business is relatively small, so probably you would benefit more from using a SaaS solution developed by a startup rather than employing your own people to do that. And actually, if investors, if startup entrepreneurs decide that an application like this makes sense commercially, they will be happy to develop something for you. But it's best if they make this decision, not you. And I do hope that if you do start something like this, you will find our frameworks useful.